Okay, so today we are going to look at mobile pen testing, and it's going to be very exciting because we are going to go through just a sec. Right. Which slide should that? Let me know if you can see what I'm presenting.
Yep.
Okay, perfect. All right, so today we are looking at mobile pen testing, and we are going to focus on Android. Android is a special operating system, so we are going to look at how, people say iOS is more, what's the word they use? iOS is more secure, Android is more secure, it's less secure, blah, 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 blah. So today we are going to look at why. And there's a reason why we are trying our attack on, we are doing this on Android and not iOS. So we'll see why as we move on. Okay, so we're going to look at an overview of mobile pen testing, Android, what activities are intent, service, broadcast receivers, and then we'll take a look at what Java is, a basic history about Java, the classes, what classes are, packages involved in Java, and then we're also going to look at APK files. For those of you that have used an Android, if you download an app, if you download an app from other sources, you would realize that the extension, just like a PDF file for Android, it's APK files. And then also we would check what tools we can use to analyze Android APKs or Android files. And then we'll do a demo. And I agree with Jason, it is going to be fun. All right, so mobile testing, mobile pen testing is more about vulnerable applications than the operating system itself. Okay, I know most people are like, oh, the Android OS is weak, but then that most of the time, if people are doing mobile pen testing, the target is the applications that are installed on there instead of the operating system. Sometimes the operating system comes into play, but not all the time. And then from this perspective, Apple's iOS is considered more secure because they vet each and every submission to their app store, right? This is why. Before your app would be on the app store, you have to vet it. Before you could even install it on the device, the device has to check for certain certifications, unless maybe you jailbreak your iPhone, right? In the past, you could sideload an app, or you could download apps from websites directly onto your iPhone. You would have to approve a certification. On your phone, you have to approve a certification, and then probably approve a profile. There's something called a profile. Do all of that, and then the app will be running for a while. Then after 2 weeks, all of a sudden you open the app and the app is not running because it didn't come from the store. I don't know how they find their way to find all these apps that are not legit, but I've had some of these apps in the past on my phone, and somehow after a few weeks, they stopped my flow. So it was sad, but that's in the past, and I've forgiven Apple. So, but then Google's Android. So Android is obviously an operating system developed by Google, and it makes up 72% of all cellular users, right? Mobile phone users. And they allow you to install applications from untrusted and unvetted sources, making them a great choice for pen testing with stable applications. So this point is that with iPhone, your apps need to come from their store. Otherwise, it won't be, even if it gets on the phone, after a while, you'll notice that the app is not working, unless maybe you jailbreak or you sideload the app, which is connected by USB, and install the app and all of that, right? But with Google, there is a setting within the phone where you could just say that allow apps from untrusted or from external sources, which means even if the app is not coming from the App Store, right, still install it. That's the whole idea. Now, this looks like, because at a point, most people were not downloading. Sometimes people don't download their apps from the Google Play Store. They download it from external places. I used to do that in the past. If I want to play a game and I don't want to download the whole 3 gig at once, there are websites I could go where they would give me the APK file and the data file, and I download them, then I put it on the phone without taking it from the store. Even at a point, I'm saying this unofficially, right? I can't go to court for this, but then there were certain apps that people were not paying for that they could install on their devices, and it was coming from external sources, which was not the Google Play Store. Now, to allow these installations, Google is the Android operating system is an open source operating system. So they decided that, okay, let's give people that freedom to, I mean, one thing most Android users will say is, Android gives me the freedom. Once they use an iPhone, they're like, oh, iPhone, there's no freedom, there's no freedom. So that idea that they have that freedom to install anything they want, do anything they want, that is where it comes from. So they're able to install apps. I can develop an app and install it on my phone here and there. I think I've done that before. That was about 2015. I developed this, I think it was an Android app. I think that was my first. I did a notebook application, placed it on my phone at the time, and it worked. I mean, I couldn't share the app with people because I know there'll be bugs, but to me, every time I wake up, I see that app, I felt like I was the best developer in the world. But I mean, I think I was just overhyping myself. But that was the idea where you could install anything you want on Android devices. So due to that, like it's easy for people to attack, because most of these apps that we download from external sources, which is not the Play Store, has not been vetted for malware, has not been inspected. Like, there is nothing going on. So at the end of the day, if I scan the device and I find that this phone is installed, I can find a way to exploit. And I find that this app is installed, I can find a way to exploit that app based on the app's own poor security features. So a lot of users do not update their software, and a study shows that 34% of Android users, that's about 1/3, of Android users are running an outdated OS. Now, this is not because the users decide not to update the Android OS. It's just because that there are so many Android handsets on the market. And due to that, it's very difficult. For example, if I'm, let's say, Samsung, right? Samsung has like about over 10 different phone models they design, right? And so at the end of the day, once they do that, the next year they want to bring on new models. So now those phones, they have 15 different models on the market. The next year they add 2 more just to entice the market. So if there's a new Android operating system version, now they have to deploy this operating system on all their devices, make sure it works, make sure it doesn't mess with system performance and all of that. And it's a lot of work. So most of these device manufacturers don't bother sort of testing these updates from Android on their devices. So at the end of the day, they only test these OSs on their flagship devices. So maybe the Samsung Galaxy S22, they will test the OS on it, make sure it works, modify it a bit. But then maybe Samsung, they had a small device called a Samsung Pocket. So for maybe the Pocket, they will be like, oh, this is old, we don't need to put any updates on it. So the device manufacturers themselves do not want to go through the stress of updating or testing these new updates on their devices. So therefore, they don't even push it to their customers or the users. But at the same time, with iOS, or on the other hand, with iOS, what happens is they don't have lots of devices to test against. They have like, maybe there's a 7 plus, 8 plus, X, XR. These are not lots of devices. So it's easy for them to just test these, like they bring up a new OS, or if they bring iOS, I think now they're on 16, or I might be wrong, but they bring a new one, they test it out, they notice everything is fine, they just push it to their customers. It doesn't take long for Apple to push updates. But then for most Android devices, it's very hard to get updates unless the devices are flagship devices. But then these numbers you are seeing here may not be the current numbers. As at the time, I think this is a bit outdated, but maybe it's better now, or maybe it's worse. It could be either of the two. Now, within the Android, if you are programming an Android application, there's what we call an Android activity. So today we are going to get messy a bit, going to how Android apps are created, what happens and what an activity is, so that when we get into the demo where I'm showing you the files of an Android app or APK, you would understand that these are the things we talked about now. So an Android activity is one screen on the UI of an Android app. So it's just like if you have a website, you see there are pages on the website. If you click on the home page, it takes you somewhere. You click on the about page, it takes you somewhere. That is what the activities are. But then this is a native Android application. So for example, from the application we see on the screen, if the user puts in the data and they click send text back, it would open this new page, right? Wait, I think it started from here. Good. It started from here. So this is the main activity most of the time. So with this page, there's the text and then there is a button. So when the user clicked on the button, it brought them here. And then once they put in data here, they click on send text back, it will take them back to the first page, right? Now, the page you are seeing is what we call an activity. So we call them Android activities. And these activities have a name, right? On mobile, on websites, we could call these the home page. This is the equivalent. This would be the home page. And then maybe this would be something like maybe a register page, right? So if this was an Android application, if this is an Android application, this page would have been named something like this. Homepage activity. This would have been named register activity. I hope that's clear. So that is where the similarities come in, just to specify the pages. So if you have a password manager and it prompts you to input a PIN, that's an activity, right? That prompt is a PIN. When you input your PIN and see all your passwords, that's a second activity. So for those of you that use LastPass and all of that, it's the same thing. But technically, once you move from one page to the other, you are moving through different activities on an Android operating system. Now, when you launch an application or any Android application, the first page you see is named the main activity, which we see here. Most of the time, it stays the same because it has to be named main activity so that the application can reference it. Now, any other page could have any other name, but the main activity should always exist. So when you launch an Android application, the main activity is created and it goes through 3 states. So when the page shows up, what happens is Android will create that main activity or that page and show it to you, right? And then it would move into the started state. So if you decide to leave the app, for those of you that have an iPhone, in similar fashion, if you just press when the home button existed, right? Or when you swipe up to go to the home screen, right? What happens is that whatever activity that is on the page would be paused. If you go back into your recent applications, you go back into the app, we say that the activity has been resumed. So that is where activity is coming. So every page is similar to an activity. All right. Now there is what we call an intent. And an intent is basically a call to an action, right? So if we want to perform an action, we would use an intent. So if I'm coding, I think before Android was coded in Java and now it's changed to Kotlin, which is a little bit different, which is developed by Google themselves, right? But so an intent, for example, if I'm on a page, right? I think when I used to do it, if you want to move from one page to the other, you could use an intent for it. And what an intent is, it's basically a code that goes like this, right? Intent, open home page. I know today we are coding, but, and then you say maybe new intent, which is a new class or something. And then you'd say that, okay, I want you to go to the page named main activity, right? They will be developers, right? So the intent, this is just me calling a variable, but this is how it will look in the codes. I'm saying that this intent's name is open home page. And what it's doing is that it's going to open something. And what it's opening is the main activity we saw on the previous page. That's all it does. So intents are used to sort of run or execute a particular action. Intents are used to go to several pages. You know, that point where when you click on a button on your mobile phone, sorry, if you click on if you click on the link on the website to take you to the about page, right? Once you click, that action where the URL changes to the about page, that is what Android does. Once you click on anything on the screen, I will use this code to redirect you to the other activity. Now we have two types of intent. We have the explicit intent and then the explicit and then implicit. So for explicit intent, when you receive a message on, let's say, iMessage or WhatsApp, and it's a Microsoft Word file, I think in the past, WhatsApp could not open such files like a Microsoft Word file. You would need to have an external app to open it. But now I think they have an internal word processor. But maybe you have received an email, all right, and then the email contains an Excel file, right? But once you receive that Excel file, when you click on that Excel file, if whatever phone you have, it would show up apps that you can use to open it. You guys are aware of that. Whenever you click on a file in a different app, it would show up that, okay, we have, it could pop up and just show you that, okay, we have Microsoft Excel on this phone. We have, let's say, Google Drive on this phone or Google Sheets that can open this file. It will show you these two files, right? Now in Android, if you want to perform such an activity, you would need an implicit intent, where with this, you don't specify which app you want it to open. All you're saying is, hey, I have an Excel file and I want you to open it. So the operating system will just show up a list of options that could open it. So those ones is where the implicit intent comes in. And then with explicit intent, you explicitly state what app should open it. So I created my notebook app so many years ago. And let's say if I have an Excel file within there, I could just tell Android that, hey, I want you to open, right? New intent. And then I'll do into bracket. I want you to open this application named maybe Microsoft Excel. So this will be the name, Microsoft Excel on the phone, right? Microsoft Excel. With this approach, I have explicitly stated what application should open the file. But with the implicit one, all I do is I'll just change this and say that whatever I'm bringing is an XLS. I think Excel has this thing, this extension. So whatever I'm bringing is an XLS file. So look within your operating system and find me something like that that can open what I have to open. So that is the difference between the two. Implicit, you don't specify what should open directly, but with explicit, you specify directly, use this application to open it or open this page in my app. All right. Within the same Android operating system, we have what we call services. And services, so services are application components that run in the background. And it's similar to Windows services or Linux services that run in the background. You know, when I think one time I said that if you want to run Metasploit, I think, yeah, it was Metasploit. I said that if you want to run Metasploit and you try to search and it's not working, you should do this command, service PostgreSQL start. So this command is just starting a service named PostgreSQL. PostgreSQL is just like MySQL. That's it. It's also another type of database management system. So this is going to start the service. Now, when we do this, you don't see anything on the screen. All of these are running in the background. It's just like when you are using a Windows machine, and then you go to Task Manager to view the services that are running. So most of the time, these services could be running if, when we did the Python 3, right, http.server, so many times so far, what all that we were doing is that we want to start up the HTTP server service, and it's going to run in the background. We don't see anything. All we see is that files are being loaded and everything. The services are running in the background. So we have MySQL, which could exist in Android. We have SSH, which is secure shell. We already know that. Apache 2, location services. It doesn't have a graphical user interface, so you would not see anything pop up, but then it helps applications to run. So most of the time on your devices, and these concepts, I think half of the time applies to iOS as well. It's mostly the same concept. It's just that it is being implemented differently. So Android as an operating system has activities, intents, services. We will need this when we start doing the mobile pen test to see what is there when we are investigating the code. So take note of these things. All right, now we have broadcast receivers. So broadcast receivers, they are like when you launch Netcards and then you are waiting to listen for communication, right? So broadcast receivers will listen, and if a certain criteria is met, the app will change information. Technically, they are event listeners. And what event listeners do is they listen for change in events. An example of such events is incoming calls, incoming text, low battery, charging, Wi-Fi availability. So you can create an app, set up a broadcast listener within your app, and then all you're doing is, if there is a call going on, I want you to start recording. For example, my notebook app could have had some malicious code, whereby the broadcast receiver is just trying to listen for any call. So whenever a call starts, my code will look like this. So if call has started, right, is equal to true. I mean, this is not real code. This is dummy code, like pseudocode, right? Then I do something like this, start recording. So this is my broadcast receiver. It is waiting for a change in the event or situation. Once it notices that a call is coming in and the call is picked, immediately it will start recording that call, the audio of the call, and then maybe as an attacker, it will send it to me. So sometimes it is checking low battery. I think if you do a WhatsApp call now, what happens is, if I'm talking to Josh, right, and then I have like 10% battery, WhatsApp would actually send a message, will send a notification to Josh that my battery is low. I feel like that's like the highest point of snitching. Like, why don't you tell me? Why are you going to tell the person I'm talking to that my battery is low? Like, I don't know. I think they're trying to do some like some peer-to-peer, what's the word? Like trying to check accountability system. Good. Yeah, it does. You could, if you have that, you could just put your phone on 20% battery, call someone on WhatsApp. When you get to less than 20 or maybe less than 10, the person would, within the WhatsApp call, a toast or a flashing message would just show up for like 10 seconds saying that the person has a low battery. I don't know. It's like snitching at its highest. So that is an example of a broadcast receiver, right? It is checking for the low battery. Once it sees it, it sends a notification to the other person on the other end. Is Bluetooth also a broadcast receiver? So if we are talking about the term broadcast receiver without talking about Android codes, then yes, a Bluetooth is a broadcast receiver because it's able to receive information, it's able to listen for connections, and it's also able to sort of give out or send information, right? But then in this case, we are talking about broadcast receivers in a case where it is coded as part of an application. So within the code, you are listening for that connection, listening for that change in activity to work on that. I hope that answered your question. I have no idea why I put this drawing here. I wish I could like explain why there's a red and there are greens, but unfortunately no. Is there a situation where an app uses this for their own services? Yes, so I'm trying to understand how, but the thing is, if the app created those services on their own, that means they don't need broadcast receivers to check. Broadcast receivers are mostly used to sort of communicate with the Android device itself. In this case, I have an app, right? So the app is communicating with the hardware of the Android or the Android operating system to listen for change in events. And you notice that most of these events have to do with native OS operating system situations. There's an incoming call, it's the operating system that is receiving it. There's an incoming text, it's the operating system. But then in my application, there are so many ways I can use broadcast receivers. But if I want to, I might have to code it out myself to do anything I want personally. So, Jonathan, that is the difference between the two. I feel like as a developer, I would create my own codes to monitor certain situations. Mostly we'll use the broadcast receivers to monitor operating system changes. I hope that was helpful. Or you could use that to check if a service has stopped. But so then that could also meet your criteria. If you are using MySQL for something, you could use a broadcast receiver to check if that service has stopped. Right? All right. Any questions? I think looks like we already jumped into the question side before we even got to the question side. But does anyone have a question regarding what we've talked about so far? Is there any parts that was confusing? Okay, since manufacturers, Nadia is saying, since manufacturers don't push upgrades to older phones, what do you recommend on how long should you keep an Android phone before getting a new one? That is an interesting question. I think you can keep this, you can keep your Android device as long as there are no vulnerabilities for it, right? So you could, since you want to keep it, you should be the one going online to check, is there a vulnerability for this Android device? Is there another vulnerability? You know, stuff like that. But I think it's all up to you. But if it's too old, for example, if your Android is running 4.4, you know it's too old and it's very vulnerable. But if your Android device was from just 2-3 years ago, then it's, I feel like you just need to monitor. Maybe every 1 week, just go online and Google, is this version vulnerable? Just to check. I think that would help. But for that, it's all up to you as long as there are no vulnerabilities. I think even just this week, there's this critical vulnerability on iOS. And I think last week or something, they've pushed updates and all of that. So the updates, the vulnerabilities could spring up from anywhere. So it's always good to do that. But I love Android devices. So, but still, it's up to you as long as you are not being attacked, Nadia. I hope that was helpful. OEM, Josh. Yeah, OEM is original equipment manufacturer. And then EOL, is that end of life or something? Mamma mia, Josh, why? Josh.
Yeah, original engineer manufacturer, end of life.
Oh, okay. Okay. Yeah, that was a lot of things to decode. Wait, where's my...
Sorry for the alphabet soup.
You threw me off guard. Wait, where's my... Okay, can you see my screen?
Yes.
Okay. All right, now Java. We are jumping to Java. So Java is a popular programming language that was introduced to the world in 1995, and it's different from JavaScript. The names are very similar, but they don't know each other. They are like very different. So Java is a popular programming language that was introduced in 1995, created by James Gosling and his team at Sun Microservices. I think Microsystem, they are now Oracle. Probably I might be wrong, but James wanted to incorporate his programming language into refrigerators, televisions, as early as the late 1980s. And to achieve this, he made a program, the Java Virtual Machine, JVM, that would run Java programs on any processor. High level or Java code is then, so whatever code you write is then translated into intermediary code or bytecode and then translated into binary code. I don't like the fact that today my slides are lots of words. Yeah, too much words. But the whole concept of how Java came into being was that this guy James decided that he wanted programming languages to work on home appliances, right, in the 1980s. And he decided that to make that work, because whatever thing you are trying to run on might be using a different processor, a different architecture, blah, 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 on and on and on. So he decided that, okay, then he's going to create a Java virtual machine, which is a JVM. And the JVM, in that way, whatever codes you put in, it would process that code, and then it would change it into intermediary code, change it into binary code, and you can run it anywhere. So in that same way, you have your, right? So in that same way, you have your Java code here, right? Java code, and then it would be compiled into binary, right? Now it is in a different package. Let's make this like an emblem. So it's in a different package. So this way, this same code can be run on a Mac, on a Macintosh machine. The same can be run on a Windows machine. Same can be run on a Linux machine. So in that way, you don't need to install, because when it comes to programming, you might need to install lots of libraries and all of that before things will work. For example, it's like the same reason why we started using Docker, right? Docker saves us that whole, let's install a VM, or let's install the dependencies. This tool needs this and this and that. So then you run it once, it is packaged as a JVM. And then once you put it on any device, it's going to work. So in this way, this became it made it so easy that I think Java is one of the top 3 programming languages in the world. It depends on the country. In certain languages, yes, and as David said, WebSuite is written in Java. Like, it became so popular and it became universally, like, it became a universal language at the time that a lot of, like, for example, I think there are, if you know Java, I think, yeah, Java or PHP, and you go to Germany, you find lots of like developer jobs waiting for you, because they built some of these legacy applications so many years ago, and they are not ready to change it because it works. Because all of these German machines, most of these industrial machines, they programmed some of them with Java. So in a way, there's a reason why Java is still on top, right? Probably top 3 all these years, because there are still infrastructure, there are still devices that use this programming language. So in that same way, it became so popular, it was used for security doors, you know, those verification systems. You put your key card on there and then it verifies you and all of that. As far back as the 90s or the 2000s, it was possible because of JVM and Java servlets. So Java is the main programming language used to develop Android applications. And unfortunately, in recent years, Google decided to create another programming language named Kotlin. Thank you, Josh. But Kotlin, the developers love it. I've never touched it. The developers who develop it, they love it, but it will take a while. And the thing is, if your code works in Java, there's no need to change it to Kotlin because it's compatible with the old one. So most applications still run on Java and it will still work. If you use Kotlin, that means you need to have the latest operating system, blah, 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 to work. Right. So now in Java, now we're about to do some programming. So in Java, or in programming, or in object-oriented programming languages, right? Like Java, like C++, we have what we call classes, we have objects, we have attributes, methods. Anyway, let me clear the screen so that we can all see what I mean. All right, so Java is purely an object-oriented programming language. Objects are just like things we see every day, people, cars, etc. Each object is derived from a class, which is a blueprint, right? Each function of the program is divided into their own separate class and their classes, on and on and on. Let's look at this diagram here. So a class is like, I'm describing it with my hands, but the description is not coming. So the class is like the main, it encompasses everything, right? So for example, if I say, as you can see here, right? People, cars, etc., right? So we will have what we call people, and the people will be a class, right? Now, when it comes to people, each person you see, right, is derived from this class. So if you see Derek, which is myself, anywhere, you know that I was derived from the class named people. But in program, we call that an instance of a class, right? And when it comes to cars, right, can someone tell me an instance of a car? So the car is like the mother term, and then the specifics are like sort of an instance of them, or something that like something you can derive from them. Yes, so yes, the model is exactly, most of the time it's the manufacturer would be that. So we have that. So we have a sedan. So we can put sedan here, sedan or sedan. Right. So each class, which is the people class, may have class can have an object, right? So Derek is an object of the class people. A sedan is an object of the class cars. I have no idea why they decided to use the words class or objects, but that is what it means, right? So from this example here, each class may have specific attributes, right? So these attributes would be name, the age, the city, and then the gender. So that means each instance or object of that class should have these attributes. So each person should have these attributes. So if you pick Derek, my name is Derek, right? My age is 29. My city is Accra. I'm using this as a yardstick, right? And then my gender is obviously male. So this is an instance or an object that has been derived from the class people. If I pick another person, we could use the same set of attributes to define the person, right? And this is used in programming. You could program a class, put in your object, set up. Yeah, I know. I used to be a calligrapher. I used to draw those ancient arts when it comes to raw handwritings. So we have all of this, right? And then each class also has a method. So the class as the mother term, right? But then the objects in the class have the attributes, and then they also have the methods. In programming, the methods are the functions. So these are literally just functions, and this is how the functions look like. So we could say, for example, eat, right? So the eat function, a little bit of programming, which you don't need, but I'm tempted to just do it. So we could say that eat, whenever we call the eat function, we would say that put the food type here, right, in the bracket, and then we will just say that, okay, person is eating the food that I put up there. Today we are coding. So this is an example of a function. The function name is eat, or the method eats. We put in the food, and then we'll say that person is eating food. So if I do something like this, you know, we have a person named Derek, right? So if I do this in my code, Derek, right? And then I do something like, yeah, let's ignore that. If I do I need to put something here. All right. So name, comma food. So name is eating food. Good. So if I want to use that function that I just created, all I have to do is to say, hey, eat. I want to use this function, right? Now eat, then I put the name Derek. And then I put in the food, maybe let's say tacos, right? Taco Tuesday. Anyway, so once I do this, the result will be Derek is eating tacos, right? So that is the concept. If you call the function, wait, I thought I made a mistake, changed it, and now David says he likes it. So now, does it have to be plural or singular? Anyway, but yeah, don't confuse me. So, so then we have this, right? And in order to use these methods, you have to be part of this class. So for example, Josh cannot call any of these methods or cannot use eat. He can't eat, he can't study, he can't sleep, he can't play, he can't do any of that. But however, Derek can do that because he is part of the people, right? He's part of the people class or the person class. I mean, it doesn't mean Josh is not a person, but for demonstration purposes, John here can do the same thing. He can do he can eat, he can study, he can sleep, he can play. Same for Desi. But then Josh, since Josh has not been defined as an object or derived from the class, he can't do all of that. So that's like my highest level of Java programming language. And then packages, right? So packages, too much words, but then packages have a way that they are represented. Package, you know, when we were on Kali, we had something like this. Come on, I need different color. So when we were on Kali, we had the name of you remember we said everything is located in a place named user share. All the applications you install are placed in a place in this directory, user share. All right. Then we have, so on Android, most of the applications are placed in a directory named data, and then the name of the application. So the reason why I'm doing this is because 4 weeks ago, none of you were, I mean, some of you did not know where Kali was keeping these installed applications, but now you do because we've used them several times. I know that this is data because I've used it several times. So after a while, it's good to just know where it is so that you can go there directly, right? So with that being said, it would be data. And then if I install my notebook application, unfortunately, you won't see this. That is not how Android works. Android will do something very messy, and this is what it does. home.notebook. So the project name will be Derek Notebook / that is how Android would represent the notebook application I just installed. So from what I showed on the left side, this is a representation of it. So this Android's naming convention for applications. It uses com, I don't know why it uses com, but it uses the project's name and then the name of the package. So com.dereknotebook dot, it's a dot, not a slash. So then I change this to a dot. And then we have where Android is storing our application, right? Now, Android applications, once they are sort of packaged, we call it package, right? Just like zip files, right? You know, for zip files, we all know that zip files are zip files, right? But for Android, a zip file is a package. But when Android wants to bundle everything together, all the codes, once it wants to bundle them together, it would put them in a it will put them in a file, which is an APK file, right? So Android uses APK, but then with Java, the Java programming language would use a JAR file, which is a jar file. These are all extensions in simple terms. So this is for Java. This is for Android applications. And then that guy, zip, is for zip. I mean, by the yeah, just attacks. So, all right. So jars are similar to zip files, and each Java program has an entry point on and on and on and on. We can move on from there. So APK, which is the Android package. So with the Android package, we have, it contains the details used to distribute apps, and zip file, that is the Android equivalent of a jar file. I need to clear the text I wrote. All right, it's gone. So it will have the extension APK, which we see here, and it contains multiple files. So sometimes you see just a single file, APK, but then it contains a lot of information behind, so many files behind it. So when you download an app from the Google Play Store, the store will unzip the file, install the Java classes and the necessary configurations. So this is what happens when you click install on your phones. It would unzip the archive, and then it would install all the Java classes and the configuration files. Same with iOS 2. It can also be installed using the ADB, which is the Android debugger. Android debug bus. So this is the file structure for Android. Lib, the APK, once it's broken down, the archive, there's the lib, resource, assets, weights. That's too much. Too much words. I mean, this might be some of your optional assignments, but I need to upload something real quick. I need to show you guys all the things I'm talking about, the codes and everything, so that you have a visual representation of what's going on. So this is where the files are being located, and then the Android manifest an important file we'll take a look at, and then the resources ARST. Let's see, still working. All right. Now, components you need to know in an APK file: meta INF, which was in the previous one. And then we have, let's see if it's done. Yes. So this is a static analyzer for Android, but we can also use it to view the codes directly. View source code. All right. So as I've been saying, right, if whatever I uploaded was a single file named diva APK, which you did, but once the file was in there, it was broken down into the sub directories. So from what you're seeing here, whoever developed it, this is how they developed it. So there is a package name, com.this.package name, and then the name of the application. And then you would notice that there is, so these are the applications. So can you see main activity.java here, right? This is the same thing that happens when you install an Android application. Once you install it, it will break it down into, it will unzip it, take out the files, install them, sort of install the Java classes, and then your file will start to run. Interesting. So we have main activity.java here, and this is how it looks like. These are raw codes, proper object-oriented codes. Now, let's go back to our slide, right? So we have a meta. Once you unzip an APK file, you're going to find a meta.inf file, meta-inf, contains information used to run the Java program, such as entry point, which is entry point is the first page it should open, right? If you visit a website, first page it would open most of the time is the homepage. In this case, the meta.inf, the meta-inf will show you which page the application should run as the first page. And then there is a classes.des file. We will use this file shortly. It contains Java bytecode in the Dalvik exchange format. I have no idea what the Dalvik exchange format is, but when we run a Metasploit, when we run an MSF Venom code, I would use a Dalvik exchange. I don't know how they do that, but it works and I love it. Then we have resources. So resources is where the layouts of activities are located. You remember when we did HTML, CSS, JavaScript, right? So the CSS was for the beautification, right? So in Android, layouts are like the CSS. They show the design, like the pages you are seeing, the interface you are seeing here is a layout. So all these are stored in the location named resources. And then Android manifest, it lists the components of the app, such as the activities, the services, and the receivers. Let's take a look at that on the other side. So let's take a look at the Android manifest. Hopefully it should be here. Let's see. Nope, it's not. We might get that on the other side. But you would have seen all the permissions. I think we would find it. Let's go back to the static analysis page. Good. So permissions, security analysis. So this is a website that allows you to analyze an Android APK. Yes, David, that is a public void. That is how Android specifies their functions. Void are functions that do not return any value. All right. So I'm trying to analyze the manifest. Lots of juicy information. We'll get back to that. At the end of this class, we will turn into Java programmers. I can promise you that. And then, all right. So Android also has what we call a content provider, and a content provider provides an interface where two different applications can share the same data, right? For example, if I create my notebook app and I want to import the contact details. So what happens is before, each application had its own data and they were all separate, right? But using content providers, Android is able to bridge that gap where different applications can share similar data. I can ask for information from this application. This application can also get information from me. However, it has to go through the content provider, right? Any questions at this point? I know I'm going hard on the codes and the Java and all of whatnot, but the fun parts will happen shortly. Just hang in there. You're almost there. All right. Any questions? Moving on. So when it comes to analysis, we have two types of analysis. There is static analysis and then there is dynamic. Dynamic analysis happens when you run the app, you change specific things in the app to see if you are going to get some different results. Sort of, you have access to the app, so you change the codes a bit, change the parameters, change certain permissions to see if it's going to give you some information. However, static analysis is where you are analyzing the codes while the app is not running. So the page I showed, like few minutes, like just a minute ago, with the app I used, you'll notice the pages were there. And that is an example of static analysis, just going through the codes just as they are and not while it's running. So these are the two types. So tools for analyzing APK files. We have unzip. This will extract the APK files. And you can unzip it, all right, since it's an example of an archive, but the files would be encoded and you still can't read them. So when you use a tool named APK2, you are able to reverse engineer it and then get readable source code. JDGUI allows you to read or reverse engineer Java class files. And then ADB, the Android debug bridge, it gives command line interface to. We'll see all of these things in action. MobSF is what I just showed you, that website. It allows you to analyze applications in a static way, static analysis, to determine the security flaws. Now, MSF Venom comes into play again, another one. And the unfortunate thing is it's hard to do plug and play with MSF Venom. With the PHP one we did on Tuesday, PHP MSF Venom payload, we just injected it on the site and it worked. With the reverse shell we did 2 weeks ago, we just used it and it worked. But when it comes to the Android payload, it's quite difficult to run it because you need to sign the application. You remember when we did, when you did in the other tracks, you did PKI and all of that. So sometimes you need the applications to be signed. When I started, I said with iOS, every application needs to be signed and also go through a list of checks before they can be placed on the store. With Android, they brought in new security where they specify that your applications need to be signed, the manufacturer needs to be known and all of that before it will run on the new Android operating systems. However, if you use the MSF, if you use the payload on old Android versions like 4.4, maybe less than that, you don't need to sign it because at that point, that security feature had not been added to the Android operating system. So we would use MSF Venom today. I would surely incorporate this into today's class. All right, so that brings us to the end of the first half of our class. We're going to go on like a 2-3 minutes break just to wake up those that are bored along the lines. Just drink some water, and then let's get into the demo part of today. Right. So for this week's lab, we'll need an Android device. I think I have my Google Nexus 5 here, but I got that from Journey Motion. Where are you, Journey? Which you would all download for your last assignments for the week. So that's Journey Motion loading up. Some of you might encounter issues with it. I don't know why, but Journey Motion allows you to set up, no, don't download. It allows you to set up an Android device, right, on your host operating system, and it would plug that into your Kali, into your VirtualBox. So you notice I have mine here, but it's there because I set it up in this Journey Motion. So most of the time you might have to sign up, put in some email and all of that. You could use a temporary email for this. And for most of your questions regarding Journey Motion, you can consult the assignment FAQs and it would help. So when I click on the add icon on the right, I'm given the chance to choose whatever device. If I want flagship devices, I could pick that up. Google Nexus 10, Android 4.4. That's okay. Moving on. Why do I have Google Nexus? So there's Samsung Galaxy S6, S7. And then, so these are all like stock, the images of that phone and Samsung Galaxy S10, that's Android 10, right? But because I need for your assignment, I don't know which versions you would set up, but for me, I needed one where my payload will work. So I had to settle for Android 4.4, which was like 2012, 2013, thereabout. So, and then really, if you put your mouse on the I or the help icon, info icon, it shows the release date and everything. So this was released in 2021. So it's very new, Android OS 10, but wow, interesting. So if you don't prefer the devices that already exist, you could just set up a custom phone where you could modify it as much as you want. If I double click on that, I can specify the screen size, the Android version I need, up until version 10, the processors I need, and then also the network I need. It could be NAT or bridged. That is very important to choose. It's always important to choose NAT when you're doing this. So I'm going to go back. And once you click on next, you select everything, it's going to start downloading that mobile phone, just like when we do the Docker containers, it starts to download the files for the juice shop and all of that. Same thing with this. It will download everything and then it's set up. Now, once it's set up, you will notice that the phone that you just installed will be showing up in your VirtualBox. Do not run it in your VirtualBox. If you run it here, only the command line will show. So you don't. We just double click on this guy here, and it's going to run safe and sound. So you would see that for some of you, if you do your labs, you notice it's stuck over here. I think David had a workaround for that. If it's stuck on starting virtual device or something, or starting Genymotion, there are things you could do. And once again, assignment FAQs will help with that. So there we go. I have a whole Android device, Android 4.4. From which year is that from? Let's see. Wait, why is these ones all released in 2021? Well, that's a lie. But it was Android 4.4 was released in 2013, just like I said earlier. So I'm still waiting for my Android to boot up. Whilst it's booting up, we go to our Kali and then let's get some work done. It's going to boot up. Once it's done, I'll show you guys. Still booting. Thank you, David. Oh, Josh, you have oh, wait, Josh, is that what you set up in your Genymotion, or you have like the physical Nexus 5?
I have a physical Nexus 5, the bright red one from 2014, I believe.
Oh, that's good. Wow. Looks like I was being telepathic when I chose that phone. So we have then I think you could actually do some of your things with a real device if you want. All right, so this is the phone. I hope you can all see it. I hope it's big enough on the screen, but can you all see the phone on the screen?
Yes.
Okay. So this phone here is literally a phone. It can do everything. Everything. Let's go to the browser. It can do everything until it starts to freeze. Forgot to add that. Probably still setting up its stuff. So let me just go back to my Kali. Don't have the energy for this. So slow. Anyway, back to Kali to get the work done. Need to close this. Yep, so I've closed my phone. Let's just go into Kali to start work. All right, so we have a few things to do, which would start with downloading the app, which you would use for your assignments, which is the Diva app. Diva, I think the link would be on on the assignment instructions. So you are to download Diva and then start new session. All right. So let's do something like download Diva, right? I think I should have it here. Probably check my trash. Oh, no, not that one. Yep, that's the one. Yep, so this is the file we need, diva.beta.tar.gz. Take it to my Kali folder. Paste. All right, it's there. So whatever you download would be like that, just the diva is a tar.gz file, right? So tar is technically like a zipped file. So to unzip it, we need to use my Kali has been acting up for a while, just this evening, but I think we'll get through this. All right, so to unzip such a file, just have to do just ZXVF. It's V for verbose, F for file name, Z for to unzip, X for I think something I've forgotten what it is, but most of the time I use all four of them because it works. Then the name of the file will be diva. I'm trying to access this. I'm trying to just unzip it. So once I unzip it, I got the diva beta.apk, beta, any of them. And then now that I have the APK, right, I need to sort of, I told you it's the zipped file, but we could use a tool named gunzip to just check the files in there. So then we put in the diva, same name, no, not you, the other one, APK. I think, yep. I think I might need to specify directory. Diva beta APK unknown suffix ignored diva usage. Let's put the D right in front of it. We try again. Diva beta APK. Wait, the screen, oh, the command, sorry. Is it better?
Yes.
Perfect. So whilst I still try to figure out why gunzip is not responding to my special requests. Okay, so gunzip, let's just check the help file to see what we need to do. Yep, D for decompress, and then the name of the file. Let's see if I left something out. Yep, D for decompress, C for the New file name, blah, 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 blah. Diva beta.apk. Suffix ignored. Interesting times ahead. Let's see. Let's try the C. Okay, shouldn't have done that. Anyway, gunzip would have unzipped the same APK file, and then we are going to notice that it does not have the files are open, but then let's see. I would come back to gunzip at a later time. Let's see if there's a force command. Yes, there's force overwrite of output file compress links. Let's try that. Yes, I am in the right directory. Yeah, give me more ideas, guys. Let's go. Sudo. Okay, so sudo, and then F as well. Unknown suffix. Diva beta.apk. Diva beta.apk. Any ideas? Let's go. Oh, with the sudo. Sudo, we tried. But our sudo did not sudo. Try use the suffix command. Okay, I'll check that up. Let's go, let's go. Use suffix on compressed files. S. Let's see. It's taking a while. You wait. You wait for a while. Yep. I mean, once the thing is white, it means it's thinking about it. So cross our fingers and we wait. We give it like some 5 seconds, and if it doesn't respond, we move on to our next tool, which is APK2. Yep, it's gone. Let's try unzip. Yeah, that's exactly what I was going to say. Let's try unzip. Yep. From Sarah's example. Same style. Give it a file name, diva with the double A. Oh, that works. Thank you so much, Sarah. So then we have our diva file here with a double A. And then we have all these files, but if I try to click on, Android manifest, which is supposed to show us all the permissions and all of whatnot, we get not well formed, blah, 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 meaning something is preventing us from accessing it. If I try with mousepad, you will see some gibberish. Exactly. So in as much as it's a zipped, it's an archive, we have all the files in here, resources. But then the files are encoded in a way. So in order to do it properly, we need a tool named APK2. And for APK2, we need to, so for APK2, we might need to install it, right? So for those of you, it would not be in Kali automatically. So the name of our app, the same app again, Diva. Wait, what? Yeah. Yeah, divabeta.apk. So it's going to create a folder named Diva Beta. Go back here. Let's look on our Kali. Yeah, Diva Beta. Still decoding. Still working. Okay. My colleague is not responding. So all these files are unzipped into the dev beta folder. So I'm going to open that, and then you will see the same Android manifest file again. Same as I'm going to bring up the previous file. Right? We couldn't view this, but then when we use the APK tool, we would see it properly displayed. So all of these are, this is what is in the Android manifest tool. And I'm just going to go through one or two things here. So look at this section here, just these three lines. And from here, we could see these are the permissions that the application would use. If you install an app on Android, it would ask you that this app you're about to install has these permissions. So we have Android name, and the permission is to write to external storage, read that external storage, and then also access to the internet. These are the three permissions that the application would need. And they are all, it all has to be defined in the Android manifest.xml file. Then at this point, we have another one named activity. So this is XML code, right? But then we have activities, and we have about, I think, 9 of them. And so this is the name of the activity. Log activity, hard-coded activity. There should have been main activity somewhere here, but it would be stated where the app would launch and all of that. So yes, this is main activity. Main activity is here. And I told you that's mostly the first page that will be launched immediately the app is opened. So you would notice it's not added to the rest. And look at the word we have here. We have intent filter. I told you intents are used to perform an action. It could be explicit or it could be implicit. Explicit means we are specifically telling Android to do this particular task. So here, this intent, Android intent, and the action it's going to perform is to open main. I have no idea what the main is, and the launcher. Both of them, I have no idea what they are. The category is a launcher. So let's check this. Another intent, and that intent is to view credentials and also default. That is API credential. This intent is linked to this activity. So sometimes, so at this point, I don't own the app, but because I have access to the APK, what we have done is we have reverse engineered the app to view the source code. That is what we've done. So looking through this, we could find some information, know all the activities involved and which activities we should investigate. Now, closing that, we might need to view there's this file here, and in the slide, we mentioned that most of the Java code has been placed in here, so we can't really view them directly. It's in a classes.dex file. Now, when we use APK2, you don't get the DX or the DEX file when you use APK2 to or to decode the codes, you don't get that. But then if you do the unzip that Sarah helped us with, you have the classes.dex file. So our next task is to break this down so that we get all the codes directly right in front of us, okay? So I'm going to, as usual, we need to specify what we are doing for the lab so that we have a clear picture of where we are going. So we download Diva, we unzip it with unzip, diva.tar.gz, unzip Diva, and then we will use APK2 to also unzip and decode Diva files. Then we will try to convert this, because we can't view the DEX file, so we are going to convert it into Java code. I mentioned earlier that Java code is JAR, jar files, right? Java archives. So we are going to convert the DEX file. We got the DEX file from unzip to a jar file, Java archive file, so that we can view the content, right? Now we need to use a tool named D2J, which is DEX to jar, DEX to jar. So this is what we are going to do. I need to be in the folder where DEX to jar is located. So I'm going to do this command here. D2J, the DEX to jar, blah, blah, blah. D2J, DEX to jar. And then the name of the file I'm trying to work on. But then this is not going to work because I'm not in that folder. Right? So error, 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 exception, exception, exception. So we need to do it again. So I need to be in the Diva folder. So Diva, put that on the side. LS to see if we are there. That's it here. So same command. Picked up Java. Wait, do I have DEX to jar here? Let's see. Oh, yes. Thank you, Zori. Thank you, June. I mean, I like it when you guys have eagle eyes to see what I'm missing. It helps a lot. Yalla. So it's working. As you can see, .jar has been created, but it's still working on them. So whilst it's still working, let's work on our step 5. Use D2jar to convert DEX file. So it's done. Now this is the file. Then we need our last two. Our last two tools. The next two we need to sort of view these files would be, I think it's JD. I hope I remember the name of this tool. JD something, something. Just a sec, people. JDGUI, I think. So JD, that is Java. Let's see. Yeah, that's it. That's the sign. That's the sign. It's working. So this is what I will use to view the content of the code. So all I have to do is to open JD, graphical user interface, GUI, to open Java classes. That's it. So I need to find the name of the thing. Okay, I was already in the folder, so it's there. I click on that. Once I click on open, you would notice that the codes, the same thing we saw for Mob SF website. We have the same things here. All the codes have been shown. I know it's too small. I would have loved to resize my Kali, but once I do that, I can't bring it back to the previous site. So I'll go into my browser so you can see these codes properly. So now the trick is, instead of going through all of these processes in your Kali, you could just use your browser. You remember the site. Show my browser. I came onto this site, mobsf.live. I uploaded my APK, and just like you do with Virus Total. Once I uploaded my APK, there's a static analyzer at the top. I click on, I think it's even the first page. So on the first row, there should be, the third row, you see this part, decompiled code, scan options, all of that. You just click on view source code, view source. And then it's going to just open. So all the processes we did, this is the shortest form. So I would advise you guys to use this option because after all, they still give us the same file. Instead of unzipping and jzipping, the only disadvantage of this is you may not get the manifest file directly, but then you get it on the previous page before I came here. So I think, yeah, stick to mobsf.live. All the pages are here. Notes provider, main activity. So see, you remember I told you the human being is a class, the people is a class, so public class, and then all of these things in there, but then these are our codes, right? So let's go back to our Kali and then try to install the app on our Genymotion or our Android device and then move on from there. So share my full screen. Yeah, full desktop. Alrighty. Does anyone have a question so far while I turn on my Genymotion? So I can close the JDUI thing. We don't need it. I can also close this right here. All I need is the APK tool here. So, yep, I can clear this as well. Replace these steps with, replace the reverse engineering step with mobsf.live. We work smart, not hard. All right, Android still loading. With that here. Okay, so before my Android started up, you also need to make sure of the network that the Android is on. So I'm going to go into my VirtualBox, click on settings, network, and then you would see I have host adapter 1 is host only adapter. You don't touch that. Adapter 2 would be on NAT. So you have to change that to your NAT network. You specify what it is so that the two devices can communicate, your Kali can communicate with your Android device. So my Android device is all set up, ready for some action. So to find the IP address of the Android device, you could either do nmap, right, to find it, or you could just do but since you are both on the same network, it should give the same response. Or, so that would be number 9, because 1 and 2 are invalid. This is my Kali's IP. So number 9 is surely what I need. Okay. So I'm going to go into my device, right? And to check the Wi-Fi, like you can check the network. So I'm going to go into settings. Is the device big enough, people? Or it's too small on the side? Okay, good. Okay, device is loading for some reason. But whilst it loads, I know the IP address, so I don't even need to go in here. So what I can do is, there is a tool named ADB. I mentioned it earlier, Android debug bus. Yes, I think. Yeah, it's used for performing administrative activities on the device or root privileges. Like once you use it, you can connect to an Android device on your network, right? As long as it's, I mean, not on your network, but if you connect your Android, I think it could be possible. You just need to know the IP address and then cross your fingers. Okay, so Wi-Fi is on and then it's connected. So if I click on that, I have, this is the IP address in here. So that means I'm good, it's connected, right? So to do this, first thing I'm going to do is to check for ADB devices, and it's saying I have no devices connected. So to connect to my, oh, okay, thank you for confirming, Jonathan. You can do it over Wi-Fi. So to connect to an Android device, all I need to do is to say ADB connect, and then I put in the IP address of the device, right? Connected through port 5555555. As simple as that. Now, nothing shows here that I've connected, right? These are the apps. Look here, the only green thing here is messaging, and there's no green thing on the second page. We are going to install an app, and the user will not get any notification that we are about to install an app. All right. So next thing we are going to do is I need to install the Diva application, which is like the Android application equivalent of the Juice Shop, a vulnerable application that you could test yourself against. So I'm going to, so with that, I'm going to check if I'm really connected. So check devices again. And there it is, I'm connected to this device. So I would want to probably install an app. So all I'm going to say is, let's check what app we have, ls. We need to leave this directory. No. ls. If whenever you use this sign, it's equivalent to going to your home directory, your home Kali directory. Okay, so that's what I did. So I'm looking for this Diva Beta APK. So ADB install, and then the name of the app, Diva Beta.apk. Now, whilst it is working, take a look at the Android device. I told you the only green here is this. So if I execute this 100%, check here, whilst it's working, you'll notice that Diva has popped up on the mobile phone without showing the user application about to install, click yes, nothing like that. So now I've installed my vulnerable application, we can just work on it straight away. We can check for certain vulnerabilities, right? So before we work on this application, I want us to also install another application on this device. We are going to create an MSF Venom so that we can have all these tools, so that we use the last few minutes to work on the application, right? So guys, you are going to help me here. We are going to do these things. Create Android payload, right? And then we have to set up a server to transport it, which you all know how to do now. And then we need to set up a listener, right? I told you that if you do a Metapreter payload, you can't use a regular listener for that. You can't use a netcat, you need to use MSF console. So let's check I'm going to check which payloads are available for Android devices. If you are using any Android version besides 4.4, you would need to sign your payload before it gets there. So I'm going to do that one. And for that one, I'm not going to use ADB to install it. I'm going to do a direct install so that you see how it works. So I'm going to, first of all, create the payload, but we need to check what Android payloads Metasploit has. Unless I'm going into the Metasploiter. Metasploit framework payloads. Okay, there's no B. User share Metasploit framework. Let's just go back a sec. What is the name? That's models. So models payload. All right, singles. So we need singles. All right, we need Android. So same thing. We are just checking what our options are. So there is Metasploiter reverse HTTP, the same thing HTTPS, and then there is Metasploiter reverse TCP. That means our options are limited. Once you see Metasploiter, it means you can't use netcat to catch the. You can't use netcat to catch it. So we are going to pick the reverse TCP because I'm used to that instead of HTTP, HTTPS. So we'll need this guy here. So let's create our payload. So MSF Venom, right? -P, and then the payload would be Android because we are in the Android. Check here, the Android payload. So Android, and then the name of the payload is Metasploiter reverse. I'm doing this because I want you guys to see this payload thing going on several times so that it can register in your minds. So Metasploiter TCP. Next thing is the L host, which is my IP address. .4 L port, because you are using 5555. I've lost it. So let's do 55559. Someone keep that in mind. And then the format, there's no format for Android or APK in MSF Venom. So we can just do raw. That means just create it raw. We don't want anything else. And then the name would be Android reverse. Now, someone give me the code to create a Python server, HTTP server in the chat whilst I'm still doing this. The code to create a Python HTTP server, because we need to send it over to the other side. In the chat, Python HTTP server code. Yes, thank you, Jonathan. Thank you, Danny. I like it. You guys are with me. So whilst this is being created, all right, so payload is done. I think I chose stageless. So stageless is singles. Sorry. So this is why I made a decision. Singles, stages. So I chose singles because, but in this case, any of them would have worked because I'll be using Metasploit to catch it. So I'm going to open based on the command I got in the chat, Python 3 M HTTP server to catch it, to throw it. And what is the next thing I need to do? There are two things I need to do. Set up a listener, good. And because it's Metasploiter, we need to use a Metasploit for the listener. So I'm going to bring up a new terminal here. Today, I'm not going to split the screens. I'm a changed man. I hope my screen is so wide. I hope it's still visible to all of you. It's like big enough for all of you. So Metasploit console, very quick. Yo. We don't need this guy again. He has a server. This is what we need. So whilst our MSF console is still set, okay, it's on. So I just need to set up, I just need to put for the listener, which one do we need? We mostly use a particular one with handler at the end. What is the name? Multi-handler, thank you. So we can just go direct, use multi-handler. And then we need to set up few things, just 3 things: L host, L port, and then payload. So I'll set the payload first, since I already have it in mind. It's Android metaperator reverse. If at this point, this metaperator thing I'm doing, Python server, everything is confused, it's confusing anyone, just send me a message after the class and I'll schedule some time with you to explain these things, because it's important you all understand this. We are not leaving anyone behind. So set payload. Set payload. Good. So payload is set. 2 options left: L host. There's my Kali's IP address. And then L ports is 555
9.
Thank you. Felt like I tasted cold ice cream at that point. All right, so options. Looks like everything is good. It's a reverse listener, so it's going to wait, run. Now, let's come to our Android device. I'm going to all right, so I'm going to open the browser. This time I hope it responds. Please respond. That was great. Impressive too. Good. So what we need to do is to just visit my Kali's IP as always, and then so I need to find a way to stop this. Okay, so 10. All right, so I think I've done this before. So that's the URL there, 10.50.5.4, port 8000. I think I saw 200. Why is it not showing? Good. So we have everything on our screen. It's too small. See if I could find a zoom. Let's share the data. I hope it's big enough. So the file we need is named Android. I can't even see. Where are we? Was I in the right folder? Yeah, that's it. So once I click on it, it should try to download. You can see the download sign at the top, right? So I'm going to bring it down, or I could just leave this up alone. And then I'm going to go to downloads. So this is mimicking how a regular user will try to interact with the application. If I set up a fake website, the person visits, they tell them accept the notifications or accept the downloads. Once they do that, they are leaving themselves open to an attack. All right, so now I have the app. Oh, I made a mistake with the payload. I was supposed to specify .apk. Okay, let's do that again. That shouldn't take long. .apk. Let's add an S to the end of this. The way we suffered before we could get rid of the browser, and we have to do this again. So it's done. Browser again. We need to reload this page, refresh. Android shell, the server is not on. Server is on now. Reload the page. showing better? Yep, Android reverse shells with an S. So I clicked on it. I think it's downloaded now. So I can leave the browser. Go to the downloads. Yes, this one, the one I need. And our listener is still waiting. Yeah. So if I do this, an installation pop-up should show up. Good. So do you want to install this application main activity? See, this application can make a call, read text messages. All these are permissions that the payload is asking for. Record your audio, check your location, modify contact, blah, blah, blah. Now, so this is the difference between what ADB could do. With ADB, the user does not have to confirm anything. Everything happens under the radar. But with regular installation, the user will see all these. And once he installs, I click on done. I won't open it directly, but all right. So back to the menu, and that's our app, our payload on there. The main activity, right? Or you mean is it the main activity word or just the Android shell, blah, blah, blah. If it's the main activity, for that, it means that you might have to probably open the app and then you might have to change because from what I know, I just created my own app, but then it ended up being named as main activity where the user might see it. But there's a way you could hide the app and everything else. So, but then, yeah, I think there is a way to do that. I just do not have that now. So I'm going to open the app. And then our metaoperator has caught it. So that's all the app does. It doesn't even do anything. All it did was to just, once I click run, it just ran. And that's it. It doesn't do anything. So ls, no entries existing, blah, blah, blah. So I go back. ls, good, I'm in the cache and file. So now, for Android devices, you can take a screenshot, you can do a lot of things. But one thing we could do is to, we could hide the application, I think. Let's see. There should be a way to hide it. Yeah, hide app icon. So that's main activity. Let's see if it's going to go. I think main activity was hidden. So you might have to go back, come back a few times, and then, wow, good. So I think it's finally gone. So main activity is gone. So this way, at least you could hide yourself and do whatever you want. I still have access to the server. I can take a screenshot, but a screenshot, unless it's a native device, you can dump their call records, their contact SMS. I've tried this. Most of all these guys work. You could start your own activities. If you have an app, you want to start, you could start. If you want to geolocate the person, you could also do all of that. Webcam chat and all of that. But you can't, screenshots might be hard to do. So this way we have been able to exploit, but then that's not even our goal today, right? So besides creating a payload, getting it in, making it work, in this modern times, you need to sign the application. So that's an extra thing you need to do. We have an alternate lab in the slides where you have that chance to modify, where you can sign your own application and then use it, right? For newer versions of the Android APK. So I'm going to open the Diva app, because the Diva app is like OWASP's juice shop. So we are going to take some extra time today, probably 10 to 15 minutes. So for those of you that need to step off, you can. It will be recorded as usual. So there's a damn insecure, vulnerable app, and it is intentionally designed to be insecure. The aim of the app is to teach the aim of the app is to teach developers QA security. All right. So just a sec. All right, so all these are vulnerabilities that could be checked, right? So I'm going to make this our main screen right now. All right, so all these are things we could check out on this application. And the first one of them is hard coding issues. And if I click on that, so it says that find out what is hard coded and where the hard coding is. Developers sometimes will hard code sensitive information for ease. So at this point, we know that this is named hard coding. So one thing we could do is to go back into the code. So we are going to do some static analysis. The point is developers make a mistake when they are coding. So there are loopholes in whatever they have coded. So we are going to go back into the code, which we have reverse engineered. I hope you can see my screen. And I'm going to zoom in some more. Right? And we were on a page named hard coding dots. There was a hard coded thing. So we have this guy here named hard code. This one here, hard code activity.java. So I'm going to click on that, and then we take a look at a few things. Wait, is it loading? Yep, hard code activity.java. Good. So this code is a lot of codes, but let's focus on this part, which is the access part. And the first thing we see is something like this. If the text is equal to vendor secret key, right? Which means that sometimes it may not be this, sometimes it may be direct vendor keys, which should be hidden, but then it could be directly placed in the code. It's hard coded. Instead of storing it in a database and calling it whenever you need it and using it, some people decide to put that raw. So the first task is to find any hard coded information here. And this is just a placeholder. So the idea is to copy this, bring it into our wow, it's not going to allow me to paste. That is so 2002 secret key. Because if I put anything else, I get access denied, see you in hell, interestingly. So if I change it to secret key, which is what I found in the code, then I get something like access granted, see you on the other side. Now, I'm going to do one more thing, which is probably part of your assignment. So I'm going to just give you guys like a bonus with your assignment today, your last assignment. So for that, we are going to look at input validation issues, right? Where's that input validation issues number? This guy here. And then it says that try to access all the user data without knowing any username. There are 3 users by default, and your task is to output data of all 3 users with a single malicious search. Improper or no, so the hint is that improper or no input validation. On Tuesday and last week, Thursday, we dealt with this input validation thing. We dealt with one particular command, and what was that? You guys remember? Where we said if the login page or the input does not have validation, there is a particular attack that could work, and we put in some codes. What type of attack was that? SQL injection. Thank you. Yes, Edwin is even giving us the code. Going a step further. Thank you. So that is what they're saying, that when developing components that take input from outside, always validate it. For ease of testing, there are 3 ways, 3 users here. So make sure you find them. So first thing we are going to do is, if we remember our code, we did, maybe we do that. Let's see what we get. We get nothing. We get user this not found. So that means that the system was supposed to validate right? Even if I put double dash, it's supposed to validate, not check. What I'm seeing here is that whatever thing I put in, even though they are symbols, they send the symbols directly to go and check the database. So that means there is a vulnerability there. They don't validate. So we are going to do our favorite thing. What was it? It was, yeah, it was that. And then 1 is equal to 1. And then for this, we may not need our guy here. Let's see. Oh, it worked. Mamma mia. So that's it, right? So we all know if we change this to 2, it's still the same because this condition will be true. So this is a clear example of SQL injection working. So that is the whole idea of this. And in your assignment, you are supposed to sort of exploit this input validation. I've added that. The next thing is to find a way to uninstall the application. But then the thing is, in Android, you have, so all these are, let me go back here. All these are tasks you could do, but then they all have specifics on what you could do with them. The insecure data storage would also give you some specific information of what you could do, but we couldn't go deep into that today. So there is also, I think, most of you are now Google champions. If you can go on Google and then search for how to exploit Diva, right? You'll find websites that will give you walkthroughs on how to do this. And that is one resource I think would really help. Now to cap everything up, right? To finish everything up, I'm going to close this. I don't need it. Exit. Good. And then go back to my ADB devices. Okay. So I think I'm connected to, I know I'm connected, I'm just messing with it. All right, so I can do this ADB shell, and you'll see that I have root access to the shell, like the device. So I can go anywhere I want in the device because ADB gives you the access. So you don't even need to install Metapreter in there. Once you have ADB access, you could have proper access to the system. So I could go back, go anywhere I want, go into data, do all of that. Remember, for your assignments, you need to uninstall the applications and you need to know the application name. And I told you it's located in data/data. And then the application name will be com.something, right? Let me just give you a hint here. So CD, I think data is already here. So CD data, right? And then we go into CD data again. So ls, we have all these application names, see com.android.wallpaper. Then we have, see, jaka.async.diva, and this is our application. So if you want to install, you need to use this, the package name, not the name of the application, okay? So moving to Chrome, just go over, I think, the last assignments because you guys are yet to do it. So you guys need to install Genymotion. I hope I'm not logged out. We are almost done, just a minute. Then we are done for today. And also, oh, come on. Also, the surveys, I sent the surveys to you on Tuesday, yesterday. And I also sent it on Discord. I mean, I need the surveys to get better at what I do. So just do it for me. Don't do it for yourself. It wouldn't take you 5 to 10 minutes to do. So I need that feedback to know what I'm doing well, what I'm not doing well. So if you have the chance, do well to fill in the survey. Appreciate it in advance. Thank you, Zori. Zori Fapat. Anyway, just joking. So you are to download Genymotion. I think there is, oh, looks like there's a walkthrough here as well. And then you are to After Diva has installed, you have to complete task number 7, which is the input validation issues, the part 1, what I just did, the one with the SQL. And then after that, you have to install it using ADB. You have to uninstall the app using ADB. And for that, I just gave you the hints. And it's even here. Check the data category. Use the full package name, not just the name of the app. So this week would be very adventurous. Do well to finish everything by Sunday, because we have been grading your assignments if you check. So do well to